Hello, TAs for ATS 114. Dr. Shruggy here, and I want to walk you through a little bit about Lab 5. We're going to do most of Lab 5 today, but we're going to do more of the calculations and less of the actual experimentation. The lab manual, for example, has this idea that they're going to actually do some wet lab activities type stuff where they're going to be like, boiling water and melting ice and stuff like that. And it's actually really cool if they had like 3 hours to do the lab. But since they don't, we're going to start at question 10. And question 10 is really the only one of the questions that in any way refers back to that optional activity anyway, and it wouldn't have to. I mean, they just need to understand that when water is heated to the boiling point, from there on out, the water, when you keep adding heat to the water, it doesn't increase the temperature further. The heat is used to convert the liquid water into water vapor, namely steam. Okay, so anyway, we'll do question 11, which is pretty straightforward. They're going to find out that a wet playing field is going to be cooler than a dry one just because of the evaporative cooling. And they'll answer questions 12 is just a little mathematics exercise. Again, number 13 actually is just a activity where they are completing a table on the next page. Let me see if I can get over to that next page here. And so yeah, they'll just be filling out that table there on the middle of whatever that page number is, 48. Okay, then they're going to be learning about different measures of atmospheric motion, and they're going to be working with vapor pressure, mixing ratio, relative humidity, and dew point. Now, for mixing ratio and for vapor pressure, it provides them with graphs of the Clausius-Clapeyron equation, which are the graphs that help them see at any given temperature what is the saturation mixing ratio or what is the saturation vapor pressure. And that can be a tricky thing for the students sometimes. Let's just be a little bit clear about that here. So like if they know that the temperature is, I don't know, whatever on here, 25 degrees or something, they read up onto wherever that curve is here, and then they read across. Now, I know that graph that is labeled mixing ratio here, but if you thought of it as saturation mixing ratio, that would be a better way to think about it. Yeah, same with on the one that's previous, where it's mixing, where it's vapor pressure, rather. But once they have that and this idea that saturation vapor pressure or saturation mixing ratio is just a measure of how much water vapor the air could be holding, relative humidity is then a measure of how close they are to being saturated. And they do a few problems that involve these different expressions for relative humidity, for different conditions that the lab manual provides. Anyway, so yeah, sometimes they're solving for the relative humidity. Sometimes they're given the relative humidity and they have to solve for the mixing ratio, but they're very much just algebra type exercises. If at all possible, I would like them to be able to do this part that involves measuring the humidity. This is going to use that sling psychrometer, that instrument that we have where, it's two thermometers on a kind of a stick, and one of them you get wet and the other one is dry, and using that information you can figure out from those tables that are on the previous page the relative humidity. But here's the deal. The lab manual actually asks them to do 4 sites, and that seems a bit unrealistic under the time constraints. If we can find those sling psychrometers, I would recommend maybe dividing them up in groups, and one group maybe do indoors, and one group do a site outdoors, and that would be enough. They could share each other's numbers and so on, and they've gotten experience of actually using the equipment without actually having to like find 4 sites and so on. We've had semesters where students have done things like go to the gym and measure the humidity inside the showers versus we don't need to be messing with all that kind of stuff. Finally, there's a little bit of activity here where they're going to be doing the dew point. Yeah, the important thing to understand is that these graphs here, any given air parcel that you can think of maps to a location on this diagram where, the x-axis is temperature and the y-axis is what the mixing ratio is. And then if you just slide that air parcel horizontally over to where it intersects the graph of the Clausius-Clapeyron equation and read down, that's the dew point temperature. So there's not that much to it. It's just that it's a little bit fussy to read the graph because it is a little bit small. But from there on out, we're done. We're not going to do any of the heat index and apparent temperature type stuff. And I will let you know on the rubric whether we're doing any of the review questions. I'm not sure any of them are appropriate. All right, please let me know if you have any questions, and good luck with this lab, TAs.